Another popular thing to process are ram trimmings, and I went ahead and bought about 200 of them. For those who are familiar with what ram looks like, I provide an example here so you can see where the trimmings come from. So just like with the other stuff, we want to get the gold off of the ram trimmings, and to do this, we soak them in the mixture of hydrogen peroxide and hydrochloric acid. I did it a little differently here, where I added 250 milliliters of peroxide first, and then I just topped things off with the hydrochloric acid. In the end though, this is pretty much the same thing, and it doesn't really matter which way it's done. After I finished stirring it up, I just put a large watch glass on top, and I let it sit there for about a week. This time, I didn't use a bubbler to agitate things, and I would just come around a few times a day and stir things up. Then, just like you saw before, I pour all the liquid through a strainer to separate the ram trimmings. I repeatedly wet the ram trimmings with a spray bottle, and then I shook them around to dislodge any of the loose gold. I did this for a few minutes, and I was able to separate a lot of the loose gold, but just like before, we're going to have to do a secondary washing. When we look at the bowl from the side, we can see a lot of gold flakes floating around, and it looks like a decent amount has sank to the bottom. It would have been a huge mess if I added it from the bowl directly, so instead, I just scooped out small portions using a beaker. Unlike last time, this filtering step didn't take too long because I didn't wash things with way too much water, and I only had something like a liter or two to filter through. So we eventually get to the end of adding all of our greenish liquid. I wash the beaker a little, and I let the final remains drip through. While we were waiting for the last little bit to filter through, I took my strainer with the ram trimmings and I gave them a little bath. I found the gold could be removed pretty efficiently just by dipping them occasionally and then shaking the strainer around. The ram trimmings were actually pretty clean prior to this washing, so the yield is actually pretty abysmal. You might be able to see some ram trimmings with a little bit of gold still left on them, and these will be included in future batches. An entire trimming managed to make it through, so I removed that, but you can see a lot of other debris also made it. So like before, I used a beaker and I scooped the liquid out, and I added it to the filter. Once everything had been added, I washed the sides with a little bit of water to get all the gold down to the bottom. I then let all of the water filter through, and we were left with a nice little bit of gold at the bottom. I dropped the entire filter paper into a beaker, and I opened it up so that some of the gold flakes could fall out. This time, to dissolve the gold, I'll use the other method, which involves hydrochloric acid and bleach instead of nitric acid. The first part is pretty similar, where we add hydrochloric acid until everything is more or less covered. For this next part, we slowly add small amounts of bleach with a lot of stirring in between. We really want to use as little bleach as possible, so this is why we add it in small portions. When bleach is mixed with hydrochloric acid, it produces chlorine gas, and the chlorine oxidizes metallic gold to gold 3 chloride. Then, like we saw with aqua regia, the gold chloride that forms reacts further with hydrochloric acid to form chloroauric acid. Eventually, after enough bleach has been added, all of the gold has dissolved, and we're ready to filter things off. Before filtering, I first take out the stir rod. Then, just like before, I filter everything through a coffee filter, but I make sure that the coffee filter in the beaker doesn't fall in. It's important to wash out all of the gold solution from the coffee filter in the beaker, so to do this, I repeatedly add a little bit of water and then shake things around. This is done a few times, and we'll know that we're done washing things when the stuff that we pour away is colorless. Here's the final washing, and the water that we pour off is practically colorless, so we can pretty much assume that there's little to no gold left. Just as a final step, I use a squirt bottle to wash out any gold that might still remain in the filter paper. When I'm relatively satisfied that there's no gold left over in the filter paper or the funnel, I take it away. Earlier in the video, I mentioned something called the stannous chloride test, and here I'm going to demonstrate what that is. So what I do here is I take a piece of paper and I dip it into our gold solution, and then I add a little bit of stannous chloride. Stannous chloride reacts with gold in solution to form a purple precipitate. We're just using it here to test for the presence of gold, but it can also be used to differentiate between different precious metal solutions. With gold, we get a dark purple, almost black color, but with something like platinum, we can get a yellow or brown color. I just did the test here for demonstration purposes, but it's most commonly done after we precipitate the gold to make sure that there's no gold left in solution. With that being said, we move on to the precipitation step, and we add sodium metabisulfite to the solution. In the first part of the video, I added 1 spoonful, and here I used 2, and honestly, there was no real purpose for this. It's kind of just what I felt like doing. Adding a little bit of excess sodium metabisulfite isn't a huge deal, and we'll just be producing a little bit more SO2 gas. Just like before, as the gold ions react with the SO2, the solution will go from a yellow color to a colorless one, and black gold will start to precipitate out. Just by how dark the solution is here, we can actually see that we got more gold in this run than we did in the previous one. I let it sit for a while, and the majority of the gold sank to the bottom. Instead of being black here, it was more of a brown color, and evidently we can see we got a lot more than last time. To separate out the gold, we need to filter it, and unlike before where I used the proper filter paper, here I'm just going to use a coffee filter. I try to get out as much gold as I can by quickly pouring it out of the beaker, but a lot of it stays behind. To clean out the last bit of gold that remained, I just used a squirt bottle. I then went ahead and washed the sides of the filter paper to try to knock down some of the gold. I then took the coffee filter out of the funnel and I placed it somewhere to dry. This is the liquid that was filtered through, and I'm just going to do a quick stannous chloride test on it. I actually did this test before I filtered things through, but somehow I lost the footage. This test should really be done before you filter everything through, but anyway, when I test it here, it comes out negative. You can see here what it looks like when it's dry, and we're left with a nice clump of brown gold powder. For temporary storage, I transferred it to a small tram vial, and I moved on to processing a third source of gold. As I said before, this gold was generously given to me by our friend Robert Bradbury. To get things started, I took off the cap and I dropped in a small stir bar. We don't have to remove this gold from any trimmings or computer parts, so we can jump right into dissolving the gold. Out of the 2 methods that I had to dissolve the gold, I decided to use Aqua Regia. I used about a milliliter of hydrochloric acid to cover the gold, and I put in about 0.3 milliliters of nitric acid. After stirring it for just a few minutes, most of the gold had dissolved, but there was still quite a bit floating around. To get the rest of the gold to dissolve, I alternated between adding a little bit of hydrochloric acid and a little bit of nitric acid. Eventually, I got all the gold to dissolve, but you can see a lot of debris still floating around. It might look like there's a little bit of gold still left floating around, but I can assure you that it's plastic or something else and that it's not actually gold. Anyway, now that all the gold has dissolved, we can move on to filtering it. My little filtration system is made by combining a coffee filter, an elastic, and a dram vial. I figured that since I was doing this on a small scale, I might as well make some miniature apparatuses. Anyway, just like you saw previously in the video, after everything's been filtered through, we washed the vial a few times and we also washed the filter paper. Once we're done, we can remove the filter paper and we can move on to the precipitation step. I went ahead and dumped in some sodium metabisulfite to precipitate the gold, but then disaster struck. Up until this point, it seemed like everything was going so well, but unfortunately with chemistry, there's always something that goes wrong. I decided to finish processing the gold that was still in the dram vial before I moved on to salvaging what spilled out. I learned my lesson though, and from this point on, I only added small amounts of sodium metabisulfite to prevent it from bubbling over. Eventually, I've added enough, and I'm left with a colorless solution with gold floating around in it. Now I'll put the dram vial aside, and we can process the stuff that spilled. The first thing that I do is I use a pair of scissors, and I cut out the affected area. What we have here is a mix of gold in solution and a little bit of precipitated gold. The pieces of paper that were cut out were put in a beaker, and that was placed on the side, and now I washed things a little bit. Pretty much all of the precipitated gold stuck to the paper, but a lot of the gold solution soaked through. So what you're seeing now is a classic paper towel extraction, where everything is dissolved in the water that we add, and then we soak up all of the liquid using paper towel. The washing could be done a few times if you want to make sure that you get absolutely everything, but I figured I did a good enough of a job, so I only did one real washing. The paper towel and the piece of paper that we cut out was all shoved into one beaker, and we go to make some more aqua regia. All of the gold that was still in solution will just simply dissolve, but we also need to redissolve all of the gold that precipitated. This procedure is exactly the same that you saw before. We dissolve everything in aqua regia, filter things, and then we'll move on to the precipitation step. With everything filtered through, we can move on to our precipitation step, so we can dump in some sodium metabisulfite. Just like before, I swirled things around and the solution became colorless, but this time no gold really precipitated out. I think that my solution was way too dilute, so when I precipitated things, it made particles that were way too finely dispersed and they couldn't really aggregate. All of the gold from the dram vial was then isolated using a little bit of filter paper. In the end, this is the gold that we got from our various sources. On the left, we have it from the ram trimmings, in the middle is from the miscellaneous PCBs, and on the right, we have it from our friend Robert. Based on how much it cost me for the sources of the gold, I really don't think this is a worthwhile endeavor if you are thinking about using it to make money. I paid about $85 Canadian for the ram trimmings and about $40 for the miscellaneous PCBs, and both of these don't even come close to breaking even. Right now, the market price for gold is about 57 Canadian dollars for a gram, but with these sources, I'm paying about 121 if I use the ram trimmings, and about 160 if I use the PCBs. This type of gold recovery is only really worth it if you can get your sources for very cheap. At the prices I got it, it's obviously not worth it at all. With that being said, we can now move on to the next step, where I melt everything together into a nice gold button. To melt the gold, I'm going to use a melting dish that I got from Amazon. To start things off, we need to heat up the dish, and this has to be done as evenly as possible. These melting dishes can withstand very high temperatures, but they really can't handle temperature change. If the dish is heated up too quickly, or only heated in one spot, it can pretty easily crack. When I first start heating things here, I don't turn the torch on full blast, and I constantly move things around so that I don't get any hot spots. Just before we proceed further, I really want to point out that melting metal like this is not my expertise, and this is like the second time I've done it. When I thought the dish was hot enough, I started to sprinkle in a little bit of borax. When the borax here melts, it will serve as a flux, and it will prevent the gold from sticking to the dish. If it's applied correctly, the liquid gold should be able to slide around on the dish, and when we heat things up, it should all come together as one blob. The application of the borax was fine, but the dish wasn't hot enough when I added it. The borax should only be added when the dish is almost red hot, but I'm using a really bad torch here and had a hard time heating the whole thing up. If the dish were hot enough, the borax should be easily melted and form a glaze on the dish, but because it wasn't, it kinda just beat it up instead. It really wasn't ideal that there was just beads of borax, so I tried heating up the dish more and adding more borax and melting it, and it seemed to be a little bit better, but it still wasn't ideal. The filter papers that had the gold on it from earlier, I stored in the same vial that I stored the gold in, and I added everything to the dish. There was still some gold left in the glass vial, so I used some paper towel to get it out. Once everything had been added to the crucible, I started to heat things up with the torch, and I started burning away the paper. Eventually, we'll get to a point where there's really not very much paper left, and there's mostly just gold. Before we go and start to melt the gold, I add a little bit more borax on top of the remains. The addition of this borax really makes sure that I added enough, and it also prevents the gold powder from blowing away when I use the torch. Even though I was using a map torch, it really wasn't that powerful, so it took a long time to melt the gold. If we skip ahead just a few minutes, we can see that the gold is starting to melt together. This torch did work to melt the gold, but it was an absolute struggle, and it took forever to melt everything. If we skip ahead just another few minutes, we can see I'm left with a very small, poorly formed gold bead and some gold debris. I use my torch to blast the bead and liquefy it, and then I use my pliers to move the dish around so that the gold bead can pick up the other gold debris. Once we're left with a single gold bead, I take the torch off it, wait a few seconds for it to harden, and then I pick it up with a pair of pliers. Immediately out of the crucible, it actually had a pretty dark color. At this point, it's cooled down quite a bit, but I dunk it into some water anyway. After cooling things, I opened the pliers and I noticed that it was actually stuck to it by a little bit of borax. Borax is water soluble, so the button was just cracked off the pliers and then thrown into some water to clean it up. The final thing to do is to check our yield, and we see that we got between 0.76 and 0.78 grams of gold. With a little bit of calculations, we can see that the gold trimmings contributed 64% to the gold button here, 23% was from the other PCBs, and about 13% was from our friend Robert. If we multiply things out to see what each contributed in terms of mass, we get 0.5 grams, 0.18 grams, and 0.1 grams respectively. According to an infographic that I found on mining.com, 1 metric ton of e-waste can yield between 300 to 400 grams of gold. For the RAM trimmings, they're not very representative because the parts that weren't valuable were already cut off. The PCBs that I processed in part 1 of these videos is much more representative, and when I do the calculations, it seems like the infographic's pretty accurate. I use 472 grams of the PCBs, and when we do a little bit of math, we see that we should be getting between 0.14 and 0.19 grams. We actually got 0.18 grams, which falls perfectly within this window. Anyway, just as a conclusion, processing e-waste can be pretty fun, but it's really not worth it unless you can do it in large quantities and you can get your e-waste for cheap. I got about $11 worth of gold from a little bit more than a pound of PCBs, so if you want to make a profit on this, you're going to have to get it for much cheaper than $11 per pound. On top of this, you also have to account for the chemicals that you use, as well as the time you spend doing this. I think it's really worth doing if you're looking to just have fun, but if you're looking to cut a profit, you're going to have to do a lot more in-depth research. Anyway, that's the end of this video. I'm not sure which one I'll post next. It might be